Hello everyone, welcome to the session Object-Oriented Programming through Java. Myself Navya, I'm an assistant professor from the Department of CSIT in MLR Institutions of Technology. In this session, we are going to see a TreeSet class and a calendar class from Java collection framework. In this session, we are going to see what is a TreeSet class and what are the constructors of TreeSet and what are the methods or operations that support TreeSet class and an example program for TreeSet class and what is calendar class and methods of calendar class and an example program which demonstrates the calendar class. So coming to the TreeSet class, what is TreeSet? TreeSet is an organized TreeSets. It is a part of a Java collection framework which is available in java.util package, and here this TreeSet class extends the abstract class and implements navable, set, clonable and serializable interfaces. So here in the elements of TreeSet are organized using the mechanism called tree. So here the TreeSet class internally uses the tree map to store elements, and the elements in the tree set are sorted. So which is an important point, sorted according to the natural ordering. And what are the points to be noted here? Tree set is a child class of abstract set and it implements the interfaces navigable set, clonable and serializable. And it does not allow us to store duplicate values and no null values are allowed. And next, the elements in the tree set are sorted according to the natural ordering. And the initial capacity of the tree set is 16. It can store 16 elements. And next, tree set is best suitable for searching operations. Coming to the constructors, there are four constructors of tree set. The first one is an empty. It will create an empty tree set and which elements will get stored by default natural sorting. And you can give the collection as elements that will store in a tree set. And comparator, it will create an empty tree set with the specified sorting order. And sorted set, this constructor is used to convert sorted set into tree set. What are the operations that you can perform on the tree set are like inserting elements, accessing and deleting elements and updating, looping, etc. So here we will see the operations. So you can insert an element into the tree set or add elements to the tree set by these two methods. The first one is add method. You can give the element add of some 5. So the 5 will be added to the tree set. And add all is a method which is used to, if I just want to have a collection of elements equals to 5, 10, 15, 20 like that. So you can give collection of elements. So all these elements will be inserted into the tree set. Coming to the update elements. There is no methods to update or change elements from the tree set. And coming to the accessing of elements. First it will return you the first or smallest element from the tree set, and last it will return you the largest or last element from the tree set, and higher it will return you the largest element, lower it return you the largest element of particular object. Okay, if no element is found, it will return you the null values. And ceiling, it will return you the smallest element of that particular object. If does not found, it will return you the null value. Floor, it will return you the largest element. And next, subset, it will return you from this element. I just want the elements from 5 to 10. So it will return you the inbuilt in between elements. What are the present elements are there in that particular range, it will return you. It returns a set of elements that lie between the given range, includes from and excludes the 2 element. And next, input stream. So you can give the stream size starting and ending. This stream produces the given stream size number of a pseudo random integer numbers conforming from starting to ending. And subset, from element you have to give from inclusive element as well as two inclusive element you has to give. It returns a set of elements that lie in between the range from the invoking tree set. And next, tail set. It returns you the set of elements that is greater or equals to that particular element from the tree set. And tail set, it will return you the set of elements greater than or equals to, and it has to check inclusive is true. If inclusive is true, if the condition is true, then it will return you the particular element. And next, head set. It returns you a set of elements that is smaller than or equals to the specified element in the invoking tree set. So the next operation is removing elements. In order to remove the elements, it will return you a remove, and if you are giving some specified element, the specified element is removed from the tree set. And remove all, if you want to give some collection of elements, it will remove all the elements. And if you give some predicate or some condition here, it removes all the elements from the tree set collection that satisfy the given predicate. And retain all, except that particular collection, the remaining elements will be deleted. And next, pole first, it will remove the first element, smallest element from the tree set. Pole last, it will remove the largest element from the tree set. And clear, it removes all the elements from the tree set. These are all the elements. The other utility elements are, first one is size. It will return you total number of elements which are present in the tree set. And is empty, it will check whether the tree set is empty or not. If the tree set is empty, it will return you true, else it will return you the false. Clone, it returns a copy of tree set. And contains, it will compare the given value with the tree set values, and if element found, then it will return you true, else it will return you the false. And contains all is a method. You are providing a collection of elements. It will check whether that collection of elements, all elements are present in the tree set or not. If the elements are present, it will return you the true, else it will return you the false. Next, equals, it will compare the specific object with the invoking tree set collection for equality. And hash code, it will return you the hash code for invoking the tree set. And next, clone, it will return you the shallow copy of tree set instance. And splitrator, it creates a splitrator over the elements in a tree set. And iterator, it will return you the iterator over the elements in the tree set or any particular order. So coming to the example program. Here, in order to use a tree set, we has to import java.util.star for sure. Tree set demo is my class name. And here I am creating a tree set of string. Okay, new string, and I am adding the elements apple, banana, orange, mango and grapes. So I am displaying the tree set first. Next, I am removing the banana. And next, after removing banana, what is a tree set I am printing. And next, I am taking the iterator here. Just I am iterating these elements. So, tree set items. So, if any next elements are present, it will return you the next. Next, I am checking contains mango. So, whether it contains mango or not. Okay. So, the tree set contains mango. Whether it contains mango or not, it will check. If it is contains mango, it will return you the true. So, the first item, what was the first item and what was the last item, and for I am printing the first and last items, and size of an tree set. And next, after after clearing, what was the tree set. This is the example program to demonstrate the tree set. So just given the same here. See here, what was the tree set? In tree set, we have inserted apple, banana, orange, mango and grapes. So apple, banana, grapes, mango and orange I have inserted. Next, after removing banana has been removed from the tree set. And next, what were the tree set items? Apple, grapes, mango and orange. So it was checking. Tree set contains mango. True. Because mango is present. Next, what was the first item? Apple. And what was the last item? Orange. And how many, the size of tree set, how many elements are present in the tree set are 4. So, after clearing the tree set, nothing has been displayed. So, this is all about the tree set in Java. Coming to the next class, calendar class. So, calendar is a built-in abstract class in Java which is used to convert the between a specified instance in a time and set calendar fields like such as month, year, hour, etc. And this class is available in java.util package. And this class implements the serializable, clonable and comparable interfaces. So what are the key points? So as a calendar class is an abstract class, we cannot create an object for it, isn't it? So we will use the starting method called calendar.getInstance to instantiate and implement the subclasses. So coming to the methods of calendar. So getInstance is a method which is used for to give you the default time zone and locale. And getTime, it returns you the date object representing invoking calendar's time value. And getTimeZone, it returns you the time zone object invoking calendar. And getCalendarTime, what type of calendar it is. So it will return you the date object from the instant date. And get is a method you has to give you the field, it will return you the value of the given calendar field. And get first day of the week, it will return you the day of the week in an integer form. And next, weeks in a week year, so it returns you the total weeks in a week year. And get week year, it will return you the week year represented in the current calendar. And next, add is a method, it adds a specified amount of time to the given calendar field. And after, it returns you if the time represented by the calendar in after the time represented by one object. And next, before time, it will return you the before time. And next, clear, it will return you the calendar field value and the time value if the calendar undefined. And clone, it will return you the copy of current object. And compare to, it will compare from one calendar with the another calendar, and it will return you the time values of two calendar objects. And complete, it sets any unset fields in the calendar field. So these are some methods. There are many more methods of calendar class. So here is an example program, a simple example program. I am taking a calendar class example is my, in order to use this calendar class, you has to import java.util.star. Okay, as this was an abstract method, you are not going to if you cannot create a reference for that. So I am using getInstance as a method, using getInstance method. And current date and time, I am printing current date and time. So directly you can use calendar. And next, current calendar type, what type of calendar, and current date and time, and current time zone, and filed year, which year, and the current day in an integer form, particular today. And next, weeks in a year, how many weeks are there in a particular year, and time in milliseconds, and available calendar types, and what was the hash code, and is this calendar support week date, and calendar string representation. In a string representation we are showing. So let us execute this program. So here in this, see here, I have got current date and time like java.util geographical Gregor calendar time, as well as field set is true, all field set, like that. And next, current date and type, this is today is Friday, August 2, 12:17 is the time, and 2024. And next, current date time zone is Asia, Calcutta is my time calendar zone. And next, filed one, it is what was the year, 2024, and current day in an integer form is 1, and 1 day. So weeks, there was 52 weeks in that particular this year, 2024, and time in milliseconds it has given now up to 12:17 how many milliseconds has been happened. And next, available calendar types are Japanese, Buddhist and Gregorian. So we are using Gregorian timing calendar. So hash code is my hash code, it has given whether if is calendar supports weekday, true. And calendar string representation, so it has given in a string representation. So this is how the calendar class can be worked on a Java program. So you can use a calendar class like this, and you can get the time instantly. So in this session we have seen what are the two. We have seen one is calendar class and one is TreeSet. So in TreeSet what we have seen, what are the operations you can perform on TreeSet and what is TreeSet, and what all operations you can perform is insertion of elements into TreeSet and deletion of elements of TreeSet, and how you can access elements from the TreeSet, and an example program for it. In the same way for the calendar, how you are going to use the calendar in Java collection framework, and what are the methods that support calendars, and what you have seen the example program for calendar. So that's all about today's session. Thank you everyone.